Okay, we're on to question 16 now. I'm going to do 16, 17, 18 now, and then 19 and 20. So this one, you've got a lock and you've got the numbers can be set between 1, 2, 3, and 4, and 5, and there are 3 of them. And you've got a digit 553 one way, the others can be set as shown above. Work out the number of different different digit numbers that can be set for the combination lock. Okay, this really looks quite complicated, but you've got a choice of 5 and a choice of 5 and a choice of 5. That word, that probability that we talked about earlier, the word and means times. So you've got a choice of 5 and a choice of 5 and a choice of 5 makes it 125. Here, how many possible different three different numbers can you have? Well, you've got a choice of 5 to begin with, and now you've got only a choice of 4 because one's been taken, and then you've got a choice of 3 because another one's been taken, and that gives you 60. Now we get to this one here, question 17. Question 17 says, okay, given that you've got all of this, find the possible values of x. Now what you need to get your head into with ratio, and there's a lot of questions on ratio now, is that we can rewrite that as x squared over 3x plus 5 is equal to 1 over 2 because of what they tell you here. And now I can multiply these two out, so I get 2x squared equals 3x plus 5. I'm going to be careful that I don't make silly mistakes. Bring everything to this side. And again, just have to be really careful because when you're rushing, especially with negative numbers, you can make silly mistakes. Right, now I've got to factorize this. It's a non-calculator, makes it tough. One way you can do is by trial and improvement. And now I'm just going to trial this. I'm guessing it's going to be simple. That's a prime number. So I'm going to guess numbers like 1 and 5. And I'm going to make one negative and one positive. And I'm going to see if I'm lucky here. Multiply this one out, I get 1x minus 10, nowhere near the 3 that I'm looking for. So that's no good. Let's try, put a 5 in there and put a minus 1 there. I put a minus because when I multiply out, I need a minus there. I get 5x there, and I get minus 2x there, 3x, but positive. Close, so this is good. I need to just swap the signs, I reckon. So let's have it as 2 minus 5x plus 1 equals 0. Let's try this one. Minus 5x plus 2x gives me my minus 3x. That's what I want. Now for this to work, x must either equal minus 1 for that bracket to equal 0, or for this bracket to equal 0, a bit more work, for that to equal 0, I need to add 5 to both sides and then divide by 2. 5 over 2, 2.5. There you go. Quite complicated, that one, but hopefully you can see how to do it now. Now question 18. Now, for the first part, you could do this now, actually. You do know how to do this, but I need to express this expression in that form there. Everything root 3, and hopefully you can see that there's a connector 3, some things are 12, and hopefully you can see actually it's 3 times 4. That makes 12. And now I can split this, so I can call it that, and I can move that in front if I want to, because I know that's 2. So I know I've got root 3, and I've got 2 lots of root 3. So overall, I've got 3 lots of root 3. 2 marks. Question 18, how's that feel? Right, now, the reason why it is question 18 is this question here. Now, this is a whole number, so this denominator has been rationalized. So I'm going to sort out that first. I'm going to rationalize the denominator, and if you remember, you have to times top and bottom by that. So you end up with root 3 at the top over root 3 times root 3 is root 9. Root 9 is 3. All to the power of 7. Now, this is an interesting one. If I sort out the top one first, root 3 can be written as 3 to the half, all to the 7. which is, you multiply that out, 3 to the 3.5. Now I want to discuss this. 3 to the 3.5 is root 3 to the 3 times root 3 to the half. If you think about it, that does make sense. 3.5 can split as 3.5. 3 to the power of 3 is 27. So that's how I'd write that. And now the bottom guy here, 3 to the power of 7. This is for the denominator. Oh, crikey. This is where it gets a bit complicated and you have to try and work it all out. So 3 times 3 times 3. Gosh. But I know what I'm going to do. Put this out as a fraction first. Watch. Ah, clever. Look at this. Why not do clever, hey? Watch. That 3 and that 7. Hello, Fendi. That cancels out. There's 3 in there, so that goes down to 4. So I've got root 3, and now I can do this. 3 to the power of 4 is 3 times 3, which is 9, times 3 times 3, which is 9. So that's 81. Oh my word, we did it. Excellent.